is where I'll start. Is everybody ready? Okay, so you have two different representations showing hours over miles. You have a ratio table and a coordinate plane. Your goal is you have to try to figure out, in this case, how many miles per hour each of these two vehicles go. So we look at Brian. We'll do Brian first. This tells us nothing, obviously, but this is where we'll start. So if it takes 3 hours to go 75 miles for that bike, how would you figure out how long or how many miles it goes in 1 hour? What operation do you need to do? God bless. Alex. Correct. So we're going to do that. And if you do 3 into 75, what do you wind up getting? Al. 3 into 75, you got to do the division, right? You're trying to figure out how many miles it goes in 1 hour. Correct. Okay, now watch how I'm going to write this. Because some of you had a ratio here. Some of you just put 25. This is going to be a unit rate is how many miles per hour that bike goes. So you want to say 25 miles per hour. That's the rate of that cycle or that bicycle. Now for Shanice, we've got to use the coordinate plane. But you have to be careful. Because at 1 hour, you have a dot that's in between 10 and 20. And you can't guess. I know it kind of looks like 15, but you're not absolutely sure. You want to pick a dot that crosses the x and the y axis at an even number. So we have a dot here at 2 hours, 30 miles. That's kind of like what the ratio is. 2 miles, 30 miles. 2 hours is 30 miles. How do you figure out how far that bike went in 1 hour? Martina. And get used to that, because that's one way you can always find unit rate, is dividing. So 2 into 30 gives us a nice even number. What do you get, Smile? And this one goes 15 miles per hour. And if you want, and doesn't confuse you, you can abbreviate it as MPH for miles per hour. So if they were to have a race, who would win? Who's going faster? M? Brian would. So that leads us to the next question. Okay, what if Shanice wants to win the bike race? She's already going 15 miles an hour, and Brian's going 25. So she needs to go faster than how many miles per hour? Jack. 5 is not faster than 25 miles per hour, bud.
30?
Okay, she would need to go higher than 25 miles per hour. You've already had it in your head that you're going to build your graph at 30 miles per hour. Okay, but what's supposed to go here is the new unit rate has to be bigger than 25, because that's the number she needs to beat. Jack took it a step further and said, okay, I'm going to make my coordinate plane to show 30 miles per hour, which is really what you should do. Don't get crazy, because bikes can't go 150 miles per hour no matter how good of a biker you are. That's too fast. So let's pick 30. Always start lower left with a 0. We know that our x-axis has got to represent hours. What is our y-axis label? What should that be? Martina. Right. Now I'm going to bring this up because I'm going to be honest with you. When you get your tests back tomorrow, some of you lost points because you did not label your axes. And it told you in the directions you need a title, you need a y-axis label, and you need an x-axis label, and those are 2 points for each of those. So some of you lost 6 points, and to me, that's silly points just for not reading the directions. Make sure you take care of all of those little things before you actually do the points. And you need a title too. In this case, we'll call it Shanice's bike ride, or Shanice's riding times. How's that? As long as it's appropriate. Our hours, we'll just keep it the same. We'll count by ones. Yeah, Alex?
I know you said you had to do y-axis and the x-axis, but did you have to write in the corner y and x?
If you did not do that, no. But I do definitely need a label.
Oh, the other thing I'm confused about is when you're like on the sides, how do you know what to count by? Like, how do you know it's like on the sides of counting by?
It can't. You're picking a number that's going to beat 25. If you count by 26s, you could do 26s. That would beat it. You could count by 30s, count by 35s. I wouldn't go higher than 35 though, because it doesn't make sense for a cyclist to be able to bike that quickly. So once you know 30 miles per hour, that's really your first point. 1 and 30. That's really your additive. That's your additive structure. Count by ones, count by 30s. Any number that's higher. If you did 25, that wouldn't be fast enough. It's got to be higher than 25. So we picked 30 because it's an even number. Most kids did. Some chose 40. We're just building this at 30 miles per hour, which is fine. And then you just basically plot your points. Should be a nice straight line, and connect your line. And that would show a rate of 30 miles per hour. Yeah, I extended this. I went all the way, right? That's fine. I didn't finish all of them, and I could continue going up until everything is labeled as well.
So you didn't need to.
Didn't need to, but it's good that you did. I just didn't do it all because of time. All right, so we go with this. What's next? Cups? No, the hours. Okay, let's do this. This also confused you. So hopefully if I show it to you once, you'll get it. All right, so these two dudes work in a movie theater, right? The manager tells them that they earn the same amount of money per hour. But Braylon and Tice do not agree. So they kept track of how much money they earned in order to determine if the manager is correct. And so their data is shown. So we have an equation for Braylon. M stands for the money he earned. H stands for hours. So this is what we do. We're going to rewrite this equation. Who remembers when you see a letter next to a number, what operation do you do? Bell. Correct. What we've got to see is how much money Braylon makes per hour. And here's where you guys got stuck. What do I need to substitute in for H to figure out how much money he makes per hour? And I think some of you realized that it was so simple that it didn't seem like it was right, but it is. What do you substitute in? You substitute in 1. Per hour is per 1 hour, how much he makes. So I'm going to substitute in 1 for H. When you do that, you've got to add the little multiplication symbol to multiply again, because you can't put a 1 next to a 0. It looks like a big long number. What's 10.50 times 1, everybody? That's with me. $10.50 per hour. And I want you to write it like that. Put the little money symbol in and write per hour, because that's really what this lesson is all about. Per mile, per second, per hour, per minute. It's all about unit rate. For Tice, we don't have an equation. We have a ratio table. The ratio table does not tell us how much he makes for one single hour. You have to figure it out. You could pick this ratio, or you could pick this ratio. It doesn't matter. But you have to do division. Which one do you want to do? 6 and 69 or 3 into 3450? Because you're going to get the same thing. What did you do, Em?
I did 3 times, I mean, 34.50 divided by 3.
Okay, let's do that. Not a whole lot of room to work here. Let me move it over. Raise the rock. Make sure that you put your decimal up in the roof. 3 goes into 3 once. Bring down Mr. 4. 3 goes into 4 once. Got to go to termination or repeating. 3 goes into 15. 5 times. 3 goes into 0, 0 times. $11.50. Is the manager right? Yes or no? No. How much more does Tice earn per hour? Jack. Check again. Just $1 more, but it's more money. Okay, now I got a question for a ticket. You ready? After 10 hours, how much more money will Tice have earned? Anthony. No, sir. After 10 hours, how much more money will Tice have earned?
Oh, I know. $10.
$10 is correct. Okay, if it's $1 more per hour, then over 10 hours, that's a total of $10 more. Ready? Got one more question for you for a ticket. How many hours would it take for Tice to earn $25 more than Braylon? How many hours would it take for him to earn $25 more than Braylon? Mogs. Nope. Martina. 25 hours. So 1 hour to $1 ratio. It's a direct 1-to-1 ratio. 1 hour, $1. 25 hours, $25. Come on up. Okay, let's move on. We kind of already did that next page where you have to explain who makes more and why. So I'm just going to move on now, I think, to the cups, right? I think the next one's the cups. Yes, the cups. So same thing, you got to try to figure out who's stacking cups at a quicker unit rate. I'm going to rewrite the equation for Kate. What do you substitute in for time? Say it. What do you think? What do you substitute in for the amount of seconds if we're trying to figure out how many cups per second? What takes the place of T?
1.
Yes, 1. 4 times 1. So she stacks at a rate of 4 cups per second. Kate is done. Now we look at Claire. And we're lucky. They don't make it difficult because you can tell right from the coordinate plane we have a dot at a whole number for both x and y axis. So at 1 hour, she can do how many cups per hour? 5 cups per second. Sorry, you're right. Per second, not per hour. So Claire's 5, Kate's 4. Understand? Are we good? Who's quicker? Who's slower? Who's quicker? Jack, who's quicker? Claire's quicker. Not by much, but she is quicker. So now they say, all right, well, if Kate wants to stack cups quicker than Claire, what must her equation be? At the very least. Alex, start me off. C equals. That would work. You could also do 7 or 8 or 9. That's fine too. Anything higher than 5 will show a faster rate than Claire. Cups. Equation, the variables aren't going to change. T for time or seconds. So those variables stay the same. Okay, ready? Question for a ticket. Ready? I'm going to give you a hard one. You want a hard one?
Yes. Yeah.
All right, you got to really think about this one. Ready? How many minutes would it take for Claire, and forget about this. Let's look at this, the existing rates. Okay, Claire, she stacks 5 cups per second. Kate stacks 4 cups per second. How many minutes, I'll make it a little bit simpler. How many more cups will Claire have stacked than Kate after 2 minutes? And I'll repeat it one more time. Listen carefully. How many more cups will Claire have stacked over Kate in 2 minutes? Mikey tags. Not 60.
Oh. Oh.
T King. 120. Because I said minutes, which is how many seconds? Well, 2 minutes is how many seconds? 120. And she stacks 1 cup per second more, so you do 1 times 120, and that's how we did it. Come on up, T King. And I think again we did the explanation verbally, so I'm not going to do this very last question because we've already did it. Is there a question at the bottom of this? Oh, I guess not. No. Let's go on to problem set. Problem set, they give you a little bit of a wrinkle in that you have to round decimals. Did anybody did it? Notice you got a repeating decimal for one of them? No? Oh, that's not a good sign. All right, we'll get to it. All right, this first page, you have to match the coordinate plane to its corresponding equation and table. Luckily, again, you have a perfect lineup for 1 second, 5 cups. So let's do the table first. Which table is showing 5 cups per second? Bridge.
B.
Good, B. And then what equation is that? Emma. Yup. Cross out B, cross out C, and as long as you got that right, the 2 remaining letters will fit into place. But let's just make sure. For this one, you don't have a dot that lines up perfectly along the y-axis for miles. You really should be using that point right there, that 2. Two hours is 30 miles. You got to figure out what it is per mile. 15. That'll help you to do the equation. The table matches up perfectly, though. There's your 2 to 30. There's your 1 to 15. So it's table D and equation A. And you could reverse this. If you put A and D, that's fine, as long as they're both there. Al?
Because it's usually
Be careful, because what if it's 16? you don't know if it's exactly in the middle or not. You can kind of get an idea of where it is, but it's not always exact. I would always pick a point that crosses the line at an even number on the both x-axis and y-axis. Okay? It's just a little bit more solid to do it that way. It's more definite. All right, this is the one that if you did this, it wound up being a repeated decimal if you got this far. I'll show you what I mean. All right, legend. How'd you figure out miles per gallon? What operation, everybody? Z. Let's do 4 into 72. It goes in evenly. You wind up getting 18. Okay, 18 for, what is that, the legend. The supreme is a little trickier. It's still division. I have a dot at 3 gallons and 50 miles. It's not going to go in evenly. Let me show it to you. 3 into 5. Come on, thank you, Anthony. 3 into 20. We can't stop. We got to keep going because we have not terminated. I got to bring this up. No, I don't want to do that. I'll leave it there. That's fine. Got to bring down another 0. I've got it now. This is really 50 with a decimal. 3 into 20. Three into 20. And it repeats, 16.6. We put a bar above that first number that repeats to show that it goes on forever. What I want you to do when that happens is if you get a decimal, round it to the nearest whole gallon. Is it closer to 16 gallons or closer to 17 gallons? Wow. 16.6. Remember what they teach you in elementary school? 5 or more, raise the score. 4 or less, let it rest. Remember that little catchphrase?
No.
No? Now you know it. 5 or more, raise the score. 4 or less, let it rest. So, 0.6 is 5 or more. You got to round it up to 17. So we're going to round this to 17. This was here. 17 miles per gallon. Okay. Right now, before we do anything further, what is the more fuel-efficient car? When you say fuel-efficient, what's getting more miles per gallon? Jack. The Legend. And I'm not going to write it all out, but it's getting 1 more mile per gallon. It's not much, but it's enough. I'm going to go down to the bottom, though. Okay, after comparing the Legend and the Supreme, Victor saw an advertisement for a third vehicle called the Lunar. The Lunar can travel about 289 miles on a tank of gas. If the gas tank can hold 17 gallons, how many, actually what it's asking is how many miles per gallon is that car getting? Because that's how you're going to make your decision. So, we're going to divide. Did anybody do it?
I did, but I didn't get it.
It winds up coming out nice and even. Anybody do it? What'd you get, Anthony? It winds up being 17. MPG, is that miles per gallon, okay? And then I think the last question is which vehicle he should choose. It still should be what vehicle? still the legend because it's still getting that 1 mile more per gallon. Okay? All right, let me tell you what your homework's going to be, of which some of you have already done it, believe it or not. Go back to your agenda. Lesson 20, which I think you can now do because it's really just a repeat and a review of lesson 19. It just gives you more practice. I'm going to tell you here in a minute. But it's lesson 20. And your page numbers, you ready? Some of you already have done it. 2 through 8. Pages 2 through 8. I think it's manageable. Okay. Some of you already got a head start. Some of you will need to step up. You could start it now, but don't group up. There's just not enough time. So start it right now. You can definitely do the warm-up and maybe get one problem done.